Okay, let's talk about how we solve linear equations. Now, a linear equation is a lot like an algebraic sentence. You'll have a left-hand side and a right-hand side with an equals in between. And we want to work these algebraic equations until we come up with some sort of numerical solution, some sort of value for an unknown. Okay, that's the purpose of us working them, trying to come up with something. Let's have a look at some easy ones, and then we'll get into some of the trickier things to be careful about. Okay, so here is my algebraic equation. A plus 27 equals 71. Well, there's a couple of really important questions you need to ask yourself. Key questions. You have to ask yourself these all the time when you're dealing with working with algebra. The first question is, what is my unknown? And in this instance, it's an A. The next question is my unknown by itself? And in this instance, it's not. It's not by itself. Then you have to say, well, what is happening to my unknown? The only thing that's happening to our unknown here is that I'm adding 27 to it. Okay, so now that I've got a bit of an idea of what my unknown is, the fact that something is happening to it, I can now work in reverse order to get my unknown by itself and to get a numerical solution. So I know that I have got 27 being added to my unknown, to my A. So I need to undo that. I need the reciprocal. I need to take 27. So I'll take 27 from both sides of the equation because I need to keep it balanced the whole time. That will then allow me to rewrite this as A is equal to 71 minus 27, which is just A is equal to 44. So there you go. We had our equation, and now we have a numerical solution for the value of A. And that's what we're trying to do as we're trying to solve these linear equations. Let's have a look at another one. This one here. Again, same questions. What's my unknown? Well, it's D in this instance. Is my D by itself? Is the unknown by itself? Well, no, it's not. It is being divided by 16. That's what's happening to it. So I need to do the reverse of this. I need to get rid of this divide by 16. But even before I do that step, this one is it's got an extra step because of this fraction, this mixed fraction. What we really need to do is to turn it back into an improper fraction, simply because it's too tricky to work with otherwise. It's so much easier if it's just an improper fraction. Okay, so what do? Well, we do 3 times 4, and that'll give us 12, plus 1 is 13. So it'll be 13 over 4. All right, so I'm going to rewrite it with 13 over 4 as my right-hand side. Okay, so D is still being divided by 16. So what do I need to do to get rid of divide by 16? Well, I do the reciprocal operator, the multiply by 16. So I will do that. I'll multiply by 16 on both sides to keep it balanced and equal. And I can just write down, with use a calculator, whatever, that D is equal to 52. And there's our numerical solution. Okay. Next example gets a little bit trickier. But it's something you need to be aware of. Here it is. There's my equation. F squared is equal to 4 over 25. Now, same thing. What is my unknown? F. Is it by itself? Well, it's on its own, but is it by itself? No, it's being squared. It's not just a single F by itself. Well, how do I undo a squared? What's the reciprocal function of a square? And that is actually to find the square root. We need to use the radical sign there, the root sign there, to be able to determine just my unknown by itself. And what I do on one side, I have to do on the other side. Okay, so this one here then, once I do the square root of f squared, that will give me an f. But my answer might be a little surprising to you. My answer is actually plus or minus 2 over 5. Now you might be wondering, well, where did this plus or minus come from? And it's important to remember that the square root of 4 actually has 2 answers. Okay. For example, one of the answers is, well, we know that 2 times 2 is equal to 4. So the square root of 4 could be a 2. But negative 2 times negative 2 is also 4, because a negative times a negative is a positive. So the square root of 4 actually has two answers. It's got positive 2 and it has a negative 2. Same goes for this 5. We know that 5 is the square root of 25, but once again, it's actually positive 5, negative 5. So when you're doing square roots of things, you have to be careful, and sometimes you'll end up with two numbers, and that's just how it is. And you use this symbol here with a plus on top of a minus to show that there's actually two answers to that one. Okay, next trickier one. What happens if we have unknowns on both sides of our equation? Here I've got 5h plus 13 is equal to 2h minus 12. Okay, my unknown is h, but what's happening to it? Well, that's really hard for me to say what exactly is happening because there's two instances of this unknown. I really need to consolidate my unknown so that it is just on one side. Okay, so what I'm going to do is I'm actually going to subtract 2h from both sides. Now, if I subtract 2h from this side, it's going to leave me with just negative 2. And my 5h minus 2h will leave me with 3h. So there's the next line, which is exactly what I said it would be. Okay, so now that we have our unknown just by itself, do I only have one unknown? Yes, I do. What's happening to it? Well, it's being multiplied by 3, and then it's having 13 added to it. So I have to work in reverse order. If the 13 was added last, it has to get moved first. So I'll do that. I will take 13 from both sides, and I will end up with 3h is equal to negative 15. I ask the question again, is my unknown by itself? No, it's not. It's being multiplied by 3. Well, how do I get rid of multiplied by 3? Well, I will divide by 3 on both sides. And that will leave me with my final answer that h is equal to negative 5. And that is my numerical solution for that particular one. All right. Another one. We've only got a couple of examples to go. Hang in there. Next one. What if I have to use other laws? What if I have to use the distributive law to open up some brackets before I can shift stuff? Well, that's okay. We can do that. We know that if we multiply this out, that we have, we do the left-hand side, we do the right-hand side. 2 multiplied by x minus 3 will give us 2x minus 6. And the other side, 10x plus 20. That's what it will be when we multiply all those things out. Do I have one unknown? No, I have two. Okay, well, I need to shift one. I always find it easy to shift the smallest one. So I'm actually going to take 2x from both sides, just like that. I'm going to end up with just a negative 6 on the left-hand side. And I'm going to end up with 8x on the right-hand side, as well as that plus 20, which is what I have. So now I need to ask the questions. Is my unknown by itself? Yes. Is it what's happening to it? Is it all alone? No, it's being multiplied by 8, and then it's having 20 added to it. So I need to work in reverse. I have to take the 20 first, which is exactly what we do. And I have to shift the screen up a bit. I'm going to get that negative 26 is equal to 8x. I then will need to look. It's not by itself yet. We have to divide both sides by 8. Once I've divided both sides by 8, I'm going to end up with negative 26 over 8 is equal to x. My x is finally by itself. That means I can stop. Well, yeah, but I can actually bring down my answer into its smallest terms, smallest relative terms. I can divide both the numerator and the denominator by 2 and get negative 13 over 4. And that one is the answer. That's our numerical solution. One last example. Here we go. All right, here is my equation. I've got 4 over 3 outside of x minus 1, and it is equal to 1 over x minus 1. Now, this one's tricky because we've got fractions that we're dealing with. Just like when we were adding and subtracting fractions, in order to be able to work with these, I need to have all of my terms have the same denominator. Okay, it's very important. So I need to look at my denominators and determine what will be the smallest common multiple. Now for this one here, the smallest common multiple will be 3 outside of x minus 1, x plus 1. That will be the smallest common multiple. So I need to look at my left-hand side. What do I need to do to my left-hand side to get the denominator to be equal to the common multiple? Well, it's already got a 3 and it's got an x minus 1. I just need to multiply this side by the x plus 1. Top and bottom of a numerator and a denominator. Okay. What about this side? Well, I've already got an x plus 1, so I need to multiply this side by 3 outside of x minus 1. So when I rewrite all of that, it will look a lot like this. And it looks confusing, but it isn't really, if you think about what we're doing. All we're doing is we are trying to get both sides of our equation to have the same denominator. Alrighto. So when I rewrite this after doing these multiplying, I'm going to end up with 4 outside of x plus 1 over our common multiple is equal to 3 outside of x minus 1 over our common multiple. You'll notice that both of those denominators are the same. Now that's really key, because as long as I do the same thing to both sides of the equation, I can keep, working. So I need to do that now. I need to multiply both sides of my equation by 3 outside of x minus 1, x plus 1 over 3 outside of x minus 1, x plus 1. Now I can multiply both sides, and I'll cheat here. I don't want that blue bit, I just want that. And I'm going to copy that side, and I'm going to do it on this side as well. Okay, and I'm going to multiply. Oh, I didn't get all of it. Oh well, what a shame. This is x plus 1, and this will have x minus 1 and x plus 1. I'm sure you get the idea. So I'm multiplying both right-hand side and left-hand side by the same sort of thing. And what will happen is it will make an error. That's what I did. I've realized I made a mistake. Let me get rid of that, and I'll start that bit again. Okay. What we want to do is we don't want to multiply it by the fraction. We just want to multiply it by the same thing on both sides. I nearly made a mistake there. I just want to multiply both sides by what is on the denominator. Okay, I want to multiply this side by the same thing. Now you might say to yourself, well, okay, why do I want to multiply both sides of my equation by that? And it's so that the denominators cancel out. This number here will cancel out with this down here, and this one will cancel out with this one down here, and I'm going to be left with just the numerators. That's all that I'll have. I'll have the numerators and no more. And now we have the numerators, it's just like that other that we were doing, where we can multiply out using our distributive law. We're then going to shift one of the x's, so we get rid of the x's on both sides. We only want x on one side of our equation. We are then going to work backwards to undo what was happening to x. I'm going to end up taking 4 from both sides, and I'm going to end up with my final answer of x is equal to -7. Okay, so it's important when you're working with fractions that you have the same denominator, and as soon as we have the same denominator, we can just get rid of the denominator. Okay, and we can just deal with the numerators. Okay, so there's some ways that we work with our working out these linear equations, actually getting a numerical solution.